to my Core Java interview questions playlist. This is the sixth video in the series. If you have been following along, you already know we have covered essential interview topics like Java fundamentals, object-oriented programming, the string class, exception handling, and multi-threading in our earlier videos. Today we are starting a brand new topic, the collections framework in Java. This is part 1 of our interview questions on collections, and we will be diving into some of the most frequently asked interview questions you are likely to face. In this video, I'll not only walk you through the key interview questions but also provide you with the clear, concise, and interview specific answers to help you stand out during your next Java interview. So let's get started. The most basic questions can be asked is, what is collection framework in Java? So the collection framework in Java is a unified architecture that provides a set of interfaces and classes for storing, organizing, and manipulating group of objects known as collections in a standard way. It is a core part of the Java platform and it is found mainly in java.util package. Next, and one of the important questions that can be asked is, explain the hierarchy of collection framework. So basically we should know all the basic interfaces and classes which are present as a part of collection framework. We can see here the red boxes are the interfaces, the green ones are the classes, and the dotted arrow line is the implements, and the solid arrow lines is extend. So we can see the collection interface is the topmost interface here. We can see three other important interfaces, list, queue, and set, which are extending collections. In list we are having ArrayList, LinkedList, vector, and there is stack, which is extending vector. In queue we are having priority queue, dq, array dq. In set we are having hash set, linked hash set, and tree set. Here we are seeing the map interface, which are having four important classes: HashMap, linked HashMap, hash table, and tree map. Map interface does not directly extend the collection framework, but it is an integral part of the collection framework. Uh, Now, as we saw earlier, that map is not implementing the collection framework. So why is the reason for it? This question can also be asked. So the map interface is a key value pair structure, whereas the collection interface is a collection of objects which are stored in a structured manner with specific access mechanisms. The main reason map does not implement collection is the add method does not support adding the key and value both, which is supported in the put method, where we are passing key and value as a parameter. Map might not implement the collection, but it is an integral part of the collection framework. So mostly the differences between two interfaces or the classes of the collection frameworks will be asked. So one is list versus set. Let us understand them with the help of features. So duplicates. List allows duplicate elements, but set does not allow duplicate elements. This is the most important feature of the set class. Order. So list maintains the insertion order, whereas there is no guarantee of insertion order in the set, but except for some implementation, which is linked hash set. Indexing. So list suppose positional access, so elements can be accessed by the index, but in set it does not support the positional access. Null elements. List can store multiple null elements, but set can store only one null element, because another null would be a duplicate one. Implementations. So some of the implementations of list are ArrayList, LinkedList, vector, stack, etc. Whereas some implementations of set is hash set, linked hash set, tree hash set, etc. Use case. Whenever there is the order is mattering or duplicates are needed, we can use list, or else when uniqueness is required, we can go with the set. Next, one of the important question is difference between array list and linked list. Let us also understand this with the help of features. So first is memory allocation. So for array, the memory size is fixed and it is allocated at compile time. But for linked list, the size is dynamic and it is allocated at runtime. Storage. Array is stored in the contiguous memory. Linked list is stored as a non-contiguous memory, which is random memory. Access time. Access time is O of 1 because we can directly access it via index. For linked list, we need sequential access and we must traverse from head. So the time complexity is O of n. Insertion. So in array, the insertion is slow because it requires shifting of elements. So the time complexity comes to O of n in the terms of insertion or deletion. In linked list, it is fast, especially if the insertion or deletion is happening at the beginning. Memory utilization. Array can be inefficient because the fixed size may waste some space, whereas memory utilization is efficient in linked list as it uses only as much as memory which is needed. Implementation complexity. So array is simple, whereas linked list is more complex because it requires pointer management. Extra memory per element. So array does not require any extra memory per element, but linked list needs some extra memory for pointers for each element. Use case. So when the size is known and frequent random access is needed, then we can go with array. And when the frequent insertion, deletion and dynamic sizes are needed, then we can go with the linked list. Uh, then this counter question can be asked after the difference, that what is the major drawback of array list when compared to linked list? So when the initial array backing an array list is full and a new element needs to be added, the array list creates a new larger array and copies the existing element into this new array. So the default copy capacity of an array list is typically 10. So say we are already having 10 elements in our array list and we try to insert the 11th element. So what it does, it resizes the array list with the 1.5 times of the current size. So the size of array would be 15 now. So when we insert the 11th element, what it will do, it will first copy the 10 elements and then insert the 11th element which we are inserting. So this copying operation can be very expensive if the list is large, as it requires iterating through all the elements and moving them to the new array. This is one of the important question which has been personally asked to me in organizations like JP Morgan and Morgan Stanley. So how to find the middle element in the linked list? So to find the middle element in linked list, the most efficient method is the slow and fast pointer approach, also known as tortoise and hare algorithm. For this, we have to initialize two pointers, which is slow pointer and fast pointer, both starting at the head of linked list. Now, in each step, we have to move slow pointer at one step and fast pointer two steps at a time. So when fast pointer reaches the end, that is fast pointer is null or fast pointer dot next is null, the slow pointer will be at the middle. So the below code is depicting the same thing. We are having slow pointer, fast pointer, both are at the head now, while fast is not equal to null and then fast dot next is not equal to null. We are doing slow equal to slow dot next, so we are moving one step ahead at a time. But for fast, we are using fast dot next dot next. So once this while loop is completed, the slow now points to the middle node. Uh, so this is the comparison of all the classes of the collection framework. So uh, since there can be multiple differences can be asked, I have compiled it to one table so we can help them understand with the help of parameters. So implements. So array list implements list, vector also implements list, hash set implements set and hash table, linked hash set implements hash set, set. Tree set implements sorted set and set. HashMap implements map. Linked HashMap implements map. Hash table implements map. And tree map implements sorted map and map. Synchronization. So array list is not synchronized, but vector is synchronized. Hash set is not synchronized. Linked hash set is also not synchronized. Tree set is also not synchronized. Hash map is also not synchronized. Linked hash map is also not synchronized, but hash table is synchronized. And again, tree map is not synchronized. So null key. since we are not having key value pair concept in array list and vector has said it is not applicable here. But in hash map, only one null key is allowed because there cannot be same key, and if we try to add one more null key, it will be basically duplicate. Linked has said only again one null key allowed. In hash table, no null keys are allowed. In free map, no null keys are allowed. Null values, uh, it is not applicable for array list and vector. For hash set, it can be only one null values. Basically, in array list, there can be multiple null values as well. Array list and vector. For hash set, there should be only one null value. Linked hash set allows only null value. Free set duplicates object are not allowed here. Uh, in HashMap, multiple null values are allowed. Linked HashMap also allows multiple null values. Hash table also hash table does not allow null values. Free map allow multiple null values. Now duplicate values. So in again in array list and vector the values can be duplicate, but hash set in hash set we cannot have duplicate values, so it is not values not allowed. Linked hash set again duplicates are not allowed. Free set again the duplicates are not allowed. In hash map it is allowed. Linked hash map also allowed, but it is not allowed in hash table and free map. Ordering, so array list is ordered, vector is also ordered, hash set is unordered. Linked hash set is ordered version of hash set. In free set the ordering is done with the help of sorting in ascending order. HashMap is unordered. Linked HashMap is ordered version of HashMap. Hash table is again unordered, and tree map is again ordered in the sorting order of sorting ascending order of the values of the key. Unique feature, so basically it array list dynamically resizes whenever it is full and increases by the 50% of its original capacity. Then vector, it increases the size by doubling the array list. Hash set does not allow duplicates. Linked hash set maintain the insertion order. Tree set uses a tree for storage in sorted order. Unique feature of hash map is it stores key value pair. Linked hash set is it maintains the insertion order for hash map. Hash table is synchronized and works with legacy codes. A unique feature of tree map is that it uses a tree for storage in sorted order. Another important question is queue versus priority queue. Let us also understand them with the help of features. So, ordering principle. In queue, it is FIFO. In priority queue, elements are removed based on their priority, not their insertion order. Element priority, in queue, there is no priority. All elements are treated equally. But in priority queue, each element has a priority. Higher, lower priority elements are served first. Implementation of queue are it is implemented using linked list or array queue, and priority queue is implemented using a heap data structure, basically priority queue class. Insertion removal, so insertion is at tail and removal is from head. In priority queue we can insert anywhere, and removal always returns the element with the highest or lowest priority on the basis of the type of the priority queue. Use case, uh, for the queue it can be task scheduling, buffering. In priority queue it can be scheduling where some tasks must be prioritized over other. Null elements, queue may allow null elements, but priority queue does not allow null elements. Time complexity, it is O of n, O of 1 for insertion and removal, but for priority queue it is O of log n for insertion and removal. Ex Next question is explain internal working of HashMap. So we can see there is multiple star marked here. So this is the most important interview question. So mostly 50% of my interview which I've given for Java, this is the first question which has been asked, and uh, next 20% interviews it is asked somewhere in the middle of the interview. So this question is mostly asked, almost 70% of the interviews it is asked. So let us understand the internal working. HashMap in Java works on hashing principle, where hash functions are used to link key and value in the HashMap. Objects are stored by calling the put method and retrieved by calling the get method. When we call the put method, the hash code method of the key object is called, which calculate an index of the bucket location where we can store the value object. To retrieve, we call the get method and again pass the key object which lends us up to at the same index or bucket, and we can retrieve the value object. Now, if two different keys return the same hash index, then the collision occurs at the time of insertion. In this case, a linked list is formed at the bucket location and a new entry is stored as the next node. Now the put method will just append the object nodes in the linked list, but if we have the linked list at the index, then we may need an extra check to search for the current value. This is done by the equals method. It checks every key of every node, and if equals return true, then map return the corresponding value from the linked list. This is again an important question. What is the time complexity of get and put methods? So in average case, the time complexity is O of 1, but in worst case, it can be O of n. It occurs when many keys hash to the same bucket, causing a long linked list at any bucket location. So the constant time performance relies on good hash function and minimal collisions. Now this is again very important question. What is the architectural changes done in HashMap in Java 8? So before Java 8, HashMap uses linked list for collision resolution. In Java 8, it introduced a hybrid approach for buckets with the few elements, like for example elements less than equal to 8 size. It uses the linked list. When the bucket exceeds 8 element, it converts it to the binary tree. So the advantage of it improves the worst case lookup, which is get time complexity, from O of n to O of log n, which is significant. So it reduces the time complexity for collision heavy scenarios. Then again, this question can also be asked, how to possibly reduce collisions in HashMap. So some things we can consider to possibly reduce collisions. One is we can use a good hash function. Second is we can increase the hash map size so that there are multiple more buckets so that the chances of collision is less. And third is we can select key types that implement efficient and well distributed hash functions. So another question is there possibility of collision even with different hash codes of the key object? Yes, the collisions can occur even with the different hash code. So reason is the final bucket location depends on hash code. It is modded with the bucket array size. For example, if we have two keys, a hash code of first key is 1025 and hash code of another key is 2049. If the bucket size is 16, we both might map to the same bucket because 1025 mod 16 is equal to 1, 2049 mod 16 is equal to 1. This is again very important question. What is load factor in HashMap? And what is the default load factor? And what happens when the load factor is reached? So load factor in HashMap is a measure that determines how full the HashMap can get before it needs to increase its capacity. It is defined as the ratio of number of entries to the number of buckets, and the default load factor is 0.75 or 75%. Now, what happens when the load factor is reached? So when the number of entries in the hash map exceeds the product of current capacity and the load factor, for example, 12 entries in a default 16 capacity hash map, then the hash map automatically increase its capacity. Typically, it doubles it and rehashes all the existing entries into the new bucket array. This process is called rehashing. Now this is one basic question which might be asked. So how to print all the keys and values of HashMap? So we can use directly .keyset method on the HashMap object. It will give return the string array of all the key, uh, and to print the values we can use the enhanced for loop, and we can directly use the get method to get the value and then print it. This is again important question, how to make hash map synchronized, since we saw in the earlier slides that the hash map is not synchronized. So to make the hash map synchronized, we are having two options. Either we can use collection.synchronized map method from the java.util.collection class. This method takes a map as a parameter and returns a synchronized thread safe map backed by the specified map, or we can use concurrent hash map. So thanks for watching this video on Java collection framework interview questions. This is the part 1 of the video. If you found this content helpful, don't forget to like, comment, share and subscribe to the channel for more valuable interview preparation material. We are just getting started with collections. Part 2 will be coming up in the next video, where we will continue with more important and advanced questions. Also, stay tuned for upcoming videos covering other crucial Java topics like interfaces, abstract classes, Java 8 features, and much more. If you have any questions or suggestions, drop them in the comments below. I always look forward to your feedback. See you in the next video.